Okay, kids, we're going to do some more bonding notes. This is page 2 of the notes. We're going to do page 2 and page 3 together. The fifth atom on the periodic table is B for boron. And boron has a 2-3 electron configuration. So we're going to show boron like this. 3 valence electrons. 2-3, but we only show the valence electrons. It's a pair and a single, and boron does not make ions in our high school class. Carbon is a 2-4 electron configuration, but we only show the carbon's valence electrons because we only show valence electrons. They show up as 2 pairs. They could be top and bottom or left and right. They also don't make ions in high school chem. Nitrogen is a 2-5 electron configuration. So nitrogen, we're going to show 5 valence electrons. Now, it doesn't matter where you put them. I'm going to put them here and here and here. So we only show the 5 valence electrons. Now, nitrogen is going to be, as a nonmetal, is going to gain enough electrons to become isoelectric to a noble gas. It's going to become N-3. And when it does that, this 5-electron nitrogen is going to gain 3 more electrons. So nitrogen as an anion, as the nitride anion, is going to have 8 dots, which we show as an ion with brackets and the charge, -3. Ions always get brackets. After that is oxygen, which is 2.6. Oxygen is going to have 6 valence electrons. They can be any way you want. I picked left, right, and top, but you could use the bottom instead. When oxygen wants to become an anion and become oxide, it's got to have 8 total electrons, so it's going to become a -2. It's got to gain 2 electrons to fill that space in at the bottom to get a full outer orbital. And we would show that as oxygen with 8 dots, but because it's now an ion, we must put it in brackets and indicate the charge to make sure everybody knows we know what we're doing. Fluorine is a 2-7. Fluorine is F with 7 dots, 7 valence electrons. This 7 right here are shown right there. When it becomes fluoride anion, it has to gain 1 electron to get a full outer orbital. It only has to gain 1 electron. So we would draw it this way with 8 dots. But since it normally only has 7, 8 is obviously an ion. It's a negative ion, an anion, and we look at it like that. Element number 10 is neon. Neon is 2-8, and that's a special electron configuration. Full outer orbitals, both of them. The little orbital is full, and the second orbital is full. Now, we would never bond neon to anything. Neon doesn't bond to anything. But if we had to, we could draw in a Lewis dot diagram. It's got all 8 dots, and that's exactly why it doesn't bond, because it's already all full up. Element 11 is sodium, which is in a 2-8-1. We're now up to 3 orbitals, period 3. Now, to show the Lewis dot diagram, we only show the valence orbital, which is 1 dot. I put it on the right, but you could put that on the left or the top or the bottom as well. Now, when it makes an ion, it's going to lose 1 electron and become a +1 ion. And to show that as a Lewis dot diagram, the sodium +1 cation becomes 2-8-0, and cations have no dots showing. Anions have the full set. Cations have empty set. Element 12 is magnesium, 2-8-2, and the Mg atom is going to have 2 electrons in its outermost orbital. They're right there. 2 in the first, 8 in the second, and then the leftover 2 in the third orbital. Now, when it becomes an ion, it must lose 2 electrons to go to a 2-8 electron configuration, which is going to be like neon. And we would show that like this. Magnesium becomes 2-8-0. And in order to show the missing 2 electrons, we would put an empty bracket with a +2 charge. Aluminum is 2-8-3. Aluminum is going to have 3 dots. I'm going to put them over here. They can go anywhere, but it'll be a pair and a single. for the 3 electrons. When aluminum loses these 3 electrons to become 2,8 like neon, it's going to become a positive 3 ion. And we would now, instead of having 2,8,3, we would have 2,8,0, and the cation again has an empty outer orbital, and that would be the Lewis dot diagram for the aluminum cation. Element 14 is silicon, and silicon on the periodic table, we can take a good look at it, and the electron configuration is, of course, 2,8,4. It's got 2 plus 8, full, and the leftover go right here. The Lewis dot diagram is actually going to look a lot like carbon's with 4 outermost electrons. Let's take a quick peek at the periodic table. Carbon is here. It's got 4 orbital electrons, 4 outer orbital electrons. Look, silicon's right below it. That's why they're in the same group 14. They have the same kind of electrons going, electron orbitals. They don't make ions in our class, okay? After silicon is phosphorus, 2,8,5, and phosphorus is going to have 5 dots. I'm going to put them like this, top, bottom, left to right, but they're going to be in 2 pairs. Now, let's look at the periodic table again. Here's phosphorus with 5 valence electrons. Look what's right above it, nitrogen. We drew the same kind of a picture. Nitrogen was 2,5. This is 2,8,5. Phosphorus is also going to have to fill that up to get 8 outermost electrons. It's going to become a negative 3 ion, just like nitrogen. And we would show that just like nitrogen, but this is a phosphide ion. We would have to have phosphorus with 8 dots and a negative 3 charge. The next one up is sulfur. Sulfur is 2,8,6. Sulfur is below oxygen. Oxygen has 6 valence electrons. Sulfur also has 6 valence electrons. So sulfur, I'm going to put them here, 6 electrons like that. Hang on. Let me see if I can pause this. Sulfur is going to have to gain 2 electrons to become a negative 2, and we would have it look like this. Same was oxygen, negative 2 ions, so is sulfur. After sulfur, we have chlorine, which is a 2,8,7. The chlorine, we're going to show the full outer orbital like that. Chlorine has to gain 1 electron to fill up its outer orbital, and we would show it with the 8 dots in brackets. It's got the full set of electrons, 8 electrons, but that's not normal. It's supposed to have 7. It's an ion that way. Now, after chlorine is, of course, argon, which is 2,8,8, another all full orbital situation. Argon doesn't ever bond, but we could still draw it as a Lewis dot diagram with all 8 electrons. After that, we have 19, which is potassium, 2,8,8,1. So we would show potassium with 1 dot. When it loses that electron, it becomes a positive 1 ion. It goes from 2,8,8,1 to 2,8,8. That makes it isoelectric to argon. To draw the Lewis dot diagram, we draw the empty outer orbital with the +1. Then we have the last one, Charlie Abuso, calcium, 2,8,8,2. Calcium has 2 dots. It's going to lose 2 electrons to become a positive 2 ion. And then we would show that with a 2,8,8,0 empty outer orbital. There we go.